Hey guys, Bryce from Trick Tools here, and I'm going to be talking to you guys about shrinker-stretchers and how they work and what the principles are of what makes them shrink and stretch. So, the concept of shrinking and stretching metal, typically when you think about moving metal, anytime you just bend metal or hammer on metal, you're stretching the metal. I guess the first thing with stretching is obviously that's usually the types of ways that people talk about stretching metal is by hammering it or by bending it in a certain way. Like if you think about bending a piece of tubing in a tubing bender, they're actually stretching that material around a die to bend it. Now when it comes to sheet metal, anytime you bend a piece of sheet metal, you still are stretching the material a little bit, and that's why if you ever bend a piece of sheet metal and then go to flatten it back out, it has some distortion in it, and it's kind of hard without the use of machinery or that type of thing to figure out how to get it to be flat again or return it to the shape from which it was. So to explain shrinker-stretcher machines, essentially like this JS Tools machine here, pretty much all shrinker-stretchers are built in the same way, where you have an upper and a lower jaw, and so basically those consist of an upper and lower jaw, and those jaws, when you're like on this machine, is a foot pedal powered machine. So when you push on the foot pedal, it forces these two jaws together, and then the force of those jaws pressed onto the sheet metal that would go in between causes the jaws themselves to do whatever action they were built to do. So on a stretch jaw, I'm going to draw this on the whiteboard so you guys can see it with a little more definition. So if you have, let's just say your jaw plates crudely look like this. So that's your upper jaw, and then you have a lower jaw here. Like I said, just drawing this crudely to get the point across. So on a stretching jaw, you don't really have a gap here. The jaw plates are together, side by side, on both top and bottom. And then as the jaws move up and down, you get the jaws coming together, and as they touch across here with the sheet metal, the way the jaws are made, and then like I said, this doesn't matter based on what machine you have. This is pretty standard across the board. These jaw plates internally are made to where when these come together, it forces on a stretching jaw, it forces each one of these jaw plates apart in this direction. So as they come down and pressure is applied in this direction, the jaw plates on both top and bottom are forced apart. And so what you have on your individual jaws is there's, now this part can vary based on what machine you have. So on this JS Tools machine, there's a certain type of texture or serration on the faces of each jaw. There's, like I said, different machines, different brands, all that have different teeth marks or texture marks on the faces of the jaw to, when the pressure is applied, those grab the metal. And so as it grabs the metal, it pulls it. As it forces apart, it comes down, grabs the metal, and then it's forced apart, which then, like I said, on a stretch jaw, it is actually in this area right here where your four jaw plates come together. It's grabbing that and it's stretching the metal in that location. So it's going to grab the metal and pull on it. So if you think of, let's just say you had some Play-Doh or some clay, something like that, and you rolled it out pretty flat, and then you grabbed it, even with your two hands, you just grabbed it like this and then pulled on it, and then you stretch it apart. That is essentially what is happening with this process here. So as opposed to hammering, where you're just providing an impact blow, which is then smashing the metal down to create the stretch, this is physically grabbing the metal and stretching it to create that stretch. So these stretch jaws in this JS machine here, like I said, to show you that, if you put your piece of sheet metal in here, and as that comes together and you apply pressure down, the jaws come apart, and then you end up, there's a little bit of distortion in this corner now, and you can see where there's teeth marks here and here, and then there's an open space there. So that's where the jaws came together, grabbed the metal, and they stretched it and pulled it apart. Now if you could measure this precisely, you would notice that that space in the middle in between those marks where the jaws grab on both sides is actually thinner than the material around it, just in that one spot. And that's why as you go down the edge of a piece of sheet metal, and you do that a couple of times, then you really start to see some distortion, because whereas this was flat and in its natural state, now you've essentially, because you've gone through and stretched down this edge, you've added more length of material in this distance, which in turn that material has to go somewhere. So that's why you end up with little waves and stuff, because the material is trying to find a location that it's happy and it's not loaded in any way. So so you can go down the edge of a piece of sheet metal, and you can also go in. So if you work your way in on a deep throat sheet machine like this JS, you can continue to walk the material in and then back out, and then you can actually see a line in the panel where it's grabbed and stretched apart down into the metal, and you have distortion deeper into the panel. Now obviously the beauty of metalworking is learning how to use machines like this to learning where you need to apply stretch in order to achieve an outcome on a panel like this. So now I'm going to explain the shrinking aspect of a shrinker stretcher machine and how it works. And so for starters, we'll draw this out. So for shrinking, again, you have the jaw plates on your dies. Again, forgive my crude drawing, but so you have your individual jaw plates that are on your jaws. Let's say this goes up this way, and so essentially with shrinking jaws, same principle. Obviously the machine brings the jaws together. This is a foot operated machine. There is hand operated machines. There's air operated machines and electric operated machines. It all depends on the level of work that you want to do and the capabilities of the machine that you need. So no matter what though, your jaws are coming together, and on a shrinking machine, if you have your piece of sheet metal in here, when these jaws come down and up accordingly, when they come together, again, the pressure of your foot or your hand that's applying that pressure to the jaws down on the piece of sheet metal, again, on a set of shrinking jaws, much like these, you have different serrations and ways of allowing the jaws to grip onto the sheet metal. And so as these come together on a shrinking jaw set, as that pressure is applied in this area, the jaw plates, because of the way that the jaws are made internally, the jaw plates are then pushed and forced in this direction, which, so as these jaws come together, they force the metal together in this way. So it's actually, if you were to look at it, if you were to do one shrink on a machine, on a piece of sheet metal, you would actually see a little bit of an area in the middle on the sheet metal that is actually a little bit thicker after you're done with the shrinking action. It's because, like I said, this comes together, it grabs the metal and it's forcing it together. And what is allowing the metal to shrink, or to get, it's essentially kind of bunching it up. It's forcing it together, and what is allowing it to do that is the gap that's in the jaws is pretty close together enough to where as it grabs the metal and is forcing it, there's really nowhere else for the metal to go. If you were to think about it in the sense of, let's say, let's take a paper towel when you're shrinking something. If you grab it too far apart, as you go to force it, it's going to just bend it. But if you grab it closer together, it's going to try to bunch it up in a smaller area, and that's exactly what it's doing here. So for instance, on some shrinking tooling, we're going to use this side here, and so as you apply pressure down, the jaw plates are then forced together after it grabs the metal, and then you see a little bit of deformation in the end of the panel here, and you can actually see on this plane, if you look down the sheet metal this way, there's actually a little raised bump right here in the middle, and that's because the metal itself has to go somewhere as it's forcing it there. So it's anywhere between those jaws there is being forced together, and then you end up with a little, you can actually physically see that metal where it's been bunched up there in the middle. So the more you do that, if you do that a handful of times down the edge of a piece of sheet metal, work your way back. So essentially what you're doing is that along the edge of this panel this way, because you're going down and shrinking and pulling that together, you're shortening the overall distance from this corner to this corner. So you're shortening that, but only where the jaws have grabbed and pulled that together. So that's why down in this area, that metal is still the same length that it was. So because now this edge is shorter in distance than it is right here, it starts to curl the metal because it's got to pull it somewhere. So that's why if you do that, you start to see how this piece of metal is curling this way, and it's curving the other way as well because it has to go somewhere. It's pulling it all together, shortening it, shrinking it, and you start to get that curve shape there. So the beauty is on this edge, where this is the edge I did the stretching on, and with a shrinker you can actually go back and shrink up some of the metal that you stretched. Say if you stretch too far, you can shrink some of that up. Now obviously it's not perfect, but it's definitely flattened this off more than it was to get it back to as close to normal as possible. So the same can be done on this side. If I quickly swap out these jaws, go back to the stretch, and grab the panel, and this is where we just did the shrinking and it created that curl on here. So if we run this back in the machine and do a little bit of stretching, you can actually see how, while not perfect, it has actually flattened the panel out a little bit this way. It still has a little bend this way, but that's just the nature of trying to unbend something that was previously bent. So, but it did take some of the curl out of the panel overall. So you can use the shrinker and stretcher aspects of these machines at the same time to be able to fine-tune shapes and to achieve the goal that you're trying to on your project. So hopefully this gives you a little more explanation on ShrinkerStretchers, how they work, what the process is between the jaws. Like I said, there's a variety of different brands of shrinker stretcher machines. There's a variety of different things that separate those brands as far as what makes them unique to themselves, but they all use the same principles as far as the jaws coming together and either stretching or shrinking the metal together using kind of a 4-plate jaw type of system. So hopefully this helps you with understanding shrinker stretchers. Thanks for watching this video, and we'll see you in the next one.